Hello, hi, this is Maath Alabdali from ACE Exams. Just before the video start, I hope you all are doing well during these surreal times. And I want to quote a famous quote by Martin Luther King, which states that our lives begin to end the day we start ignoring things that actually matter. So I just want to say that Black lives matter. Enjoy the video. So this is chemistry A level. In this video, I'm going to explain the first topic, which is the atomic structure and the periodic table. Now, I want to say that this topic is a very long topic, so it's going to be divided into parts. So this is the first part. Now, before I start, I want to say something regarding the Edexcel A-level student. So in Edexcel A-level, there are 19 topics, and in year 12, at the end of year 12, you're going to be examined on the first 10 topics, which is called the AS level. And in year 13, it includes all the 19 topics. So let's start. Now, some of the stuff you might be familiar with because some of the stuff is from GCSE. So the structure of an atom. Atom consists of fundamental particle called proton, neutron, and electron. Now, you have to know the symbol, the relative mass, and the relative charge of each subatomic particle. So, for example, proton, its symbol is P, it has a relative mass of 1, and it has a positive charge, so +1. Neutron, its symbol is N, it has a relative mass of 1, and it has no charge, so its charge is 0. Electron, its symbol is E minus, its relative mass is very, very, very small, so 1/1840, less than 1, and it has a negative charge. So each atom has a mass number and an atomic number. So one of the things that I want to clarify is in the periodic table, the mass number might not be on the top, it might be on the bottom. So you might get confused, but you have to always know that the mass number is the massive number, it's the bigger number. So over here, sodium has a mass number of 23 and an atomic number of 11. Sometime in the exam they might ask you to define what an atomic number is or mass number. So atomic number is the number of proton in the nucleus of an atom, and the mass number is the number of proton and neutron in the nucleus of an atom. Now, if the number of proton is equal to the number of electron, then the atom has a neutral charge. It is not an ion. But if the number of electrons is more than the number of proton, then the charge would be negative. It's a negative ion. If the number of proton is more than the number of electrons, then the charge is positive, positive ion. So you might be familiar with this, it's GCSE stuff. In the exam, they might ask you to define what a relative isotopic mass, or they might ask you to define relative atomic mass. They might ask you both, so you don't know. Now, one thing that I want to say is that the mass is always given in relative terms. It's relative to the carbon-12 isotope. It's an international standard. So whenever you are defining these two terms, relative isotopic mass and relative atomic mass, you have to use the carbon-12. So in this scenario, relative isotopic mass is the mass of an atom of an isotope compared to 1/12 the mass of carbon-12. So for example, over here, chlorine 35 has a mass of 35 and chlorine 37 has a mass of 37. Simple stuff. Relative atomic mass is defined as the weighted mean mass of an atom of an element compared to 1/12 of the mass of carbon-12. Now this is the definition. And the formula of the AR, which is the relative atomic mass, is the mass of an isotope times the abundance. So for example, over here, chlorine 35 has a relative mass of 34.969. So 34.969 times 75.80, which is the abundance, plus 36.966 times 24.20. You add these, you multiply both mass. First there's multiplication, then there's addition. So you multiply these two first, and then these two, and you add the answer, and you divide it by 100. So you get an answer of 35.45. This means that the relative atomic mass of chlorine is 35.45. Now, relative molecular mass and relative formula mass. So the relative molecular mass is when some compound and element are composed of simple molecules. For example, Cl2. So one Cl has a mass of 35.45. So 35.45 times 2 is 70.9. So the relative molecular mass of Cl2 is 70.9. The relative formula mass is similar to the relative molecular mass, the MR, but it's applied to ionic compounds. So, for example, sodium chloride over here. So sodium has an atomic mass of 23, and chlorine has an atomic mass of 35.45. So you add them, 23 plus 35.45 gives you 58.45. So these are four things that you need to know: relative atomic mass, relative isotopic mass, relative molecular mass, and relative formula mass. Isotope is are defined as isotope are atoms of the same element with the same atomic number but different mass number. So the same number of proton but different number of neutron. And one thing that you need to know is that isotopes have identical chemical properties. Now in the exam, you're gonna be marked for, say, like sometimes it's 5-mark question if you find isotope. So the first mark is isotope are atoms of the same element. Second mark, same atomic number. Third mark, different mass number. Fourth mark, same number of proton. Fifth mark, different number of neutron. And sometimes you can say isotope have identical chemical properties. It does not matter. So over here, we have hydrogen. Hydrogen have different isotopes. So in isotope, the mass number is different. So over here, you can see that the mass of hydrogen is different. So over here it's 1, over here it's 2, over here it's 3. So the number of proton is the same, and number of neutron is 0. Over here is 0, over here is 1, and over here is 2. Because 2 minus 1 is 1, 1 minus 1 is 0, 3 minus 1 is 2. Simple math. This is isotope of chlorine. So chlorine 35 and 17. So it has 17 protons. 35 minus 17 is 18, and this is a percentage that they might give you in the exam. Yeah, same thing. So this is where it gets a bit complicated, mass spectrometer. So a mass spectrometer, it allows you to measure the characteristics of a molecule by converting them into ions, which can be manipulated by electrical and magnetic fields. So in what do you call it? In mass spectrometer, there's going to be ionization, analyzer, and detector at the end. So over here, I summarized it in simple bullet points. So the ion source is where gaseous atoms are bombarded by electrons from a gun and are ionized. Sufficient energy is given to form the ions of +1 charge, resulting ions can be accelerated out of the ion source by an electrical field. In the analyzer is where charged particle will be deflected, and the radius of the path depend on the value of the mz mass to charge ratio, which I'm going to explain in the next slide. Then the ions of the heavier isotope with larger mz values follow a larger radius curve, and the one with the lowest mass follow the smallest mz curve, the radius curve, sorry. So most ions are singly charged with +1, and the path depend on the mass. So if an ion acquire of 2+ charge, it will be deflected more. Its mz value is halved. So yeah. So if it has a 2+ charge, then it's going to be halved. It has, if it has 4+ charge, then it's going to be 1/4. So yeah. So in the detector, it's where the ions are detected by electrical and photographic methods, and the mass spectra, or known as a mass spectrum, the mass spectra record the mz ratio and the relative abundance of each ion, and then it will be present like in a chart, which I'm going to show you in the next slide. It's called the mass spectrum. So this is the chart that I was telling you about, the mass spectrum, and in the mass spectrum, the relative abundance and the mz ratio of each ion will be shown. So the peak with the highest mz ratio is toward the right, and it's always equal to the MR. So for example, over here, um, this one, the MZ ratio, this is the MR. So isotopes such as chlorine 13 may cause a very small peak, very small peak, which can be ignored once finding the MR. So in the exam, they might give you a chart, for example, chlorine 13, and they tell you to find the MR. So you look at the peak with the highest MZ ratio, the one towards the right. But let's say you find something very small, you can ignore it. So yeah. Exam style question. So this is the periodic table that you're going to be given in the exam. Um, and this is the first question. It's quite simple. We said that if the number of proton equal to the number of electron, then it has a neutral charge. The atomic number is the number of protons, so it's going to be 19. The mass number is the number of protons and the neutrons, so it's going to be 21 plus 19, which is 40. And the symbol is the atomic number. We said it's 19, so you go and look 19 over here, 18, 19. So K, potassium, 19. Sorry, you write the mass number K40 on the top and 19 on the bottom if you want to write it. This is the first one. B, it has a neutral charge as well. The number of protons is equal to the atomic number we set. So over here it's 20. And the mass number is 40. So 40 minus 20 is 20. So neutrons is 20. Neutral charge. So the number of protons equal to the number of electrons. 20. So 20, 20, 20. Atomic number 20, 40, and we said atomic number 20. So go over here and look at 20, 20 calcium. So calcium 40 on top. It has a positive charge. So if it has a positive charge, then the number of proton is more than the number of electron by 1. So atomic number is 11. Number of protons is going to be 11 as well. 23 neutron for the number of neutron. 23 minus 11, which is 12. And we said that if the number of if it has a positive charge by 1, it means that the number of proton is more than the number of electron by 1. So 11 minus 1 is 10. And for the symbol, you go and look at the periodic table. Mass atomic number of 11, sodium, Na, 23 on the top and plus on the right. Over here, neutral charge. So the number of proton equal to the number of electrons. 6, 6, 6. Atomic number 6. Mass number 6 plus 6 is 12. And the symbol, you go and look at the periodic table. 6, carbon. Carbon 12 on top. Because the mass number is 12. Oh, sorry. Neutral charge. So the number of proton equal to the number of electron. 92, 92. 235 is the mass number, so 235 minus 92 is 143. Electrons is 92, and the atomic number is equal to the number of protons, so 92. And if you go and look at the periodic table, 92, 92, 92, uranium with 235 on top. Number of proton equal to the number of electrons, so neutral charge. And mass number is 13, so 13 minus 6 is 7. So 6, 7, 6, neutral. Atomic number is equal to the number of protons, so 6. Mass number is 13. And for the symbol, we go and look at the periodic table. 6, 6, 6, 6, 6, 6. Carbon. Carbon with 13 on top. Charge 2 minus. So, atomic number is 16. So 16 over here. And we said that if the charge is 2 minus, then the number of electron is more than the number of proton by 2. So 16 plus 2 is 18. So 16, 16, 18, 2 minus, mass number is number of proton and neutron, so 16 plus 16 is 32. 32. And for the symbol, you go and look at the periodic table, 16. Sulfur. Sulfur with 32 on top and 2 minus on the right. Over here, the symbol is given. It has a 3 plus charge, so it's an iron 3 plus. 27, so the mass number is 27. And if it's aluminium, you go and look at the periodic table. Aluminium has its atomic number is 13, so you write 13 over here. Mass number is 27, and we said that proton is equal. The atomic number is the number of protons, so 13 is the number of proton. Number of neutron is 27 minus 13, which is 14, and it has a 3 plus charge, so 13 minus 3 is 10. So electrons is 10. Yep. Next question, define relative atomic mass. So the relative atomic mass, it is the mean weighted mass, the weighted mean mass of an atom of an element compared to 1/12 of the mass of an atom of carbon-12. Next question. Oh, by the way, you can pause and solve it yourself, something like that. Isotope, we said isotope. Isotope is the atom of the same element with different number of neutron but the same number of proton, so different mass number but same atomic number. Isotope are atom of the same element with the same atomic number but different mass number, so same number of proton but different number of neutron. Next slide. I'll start question. So this question concerns the periodic table. So you go and you have to look at the periodic table. An atom of argon has a mass number of 40. Complete the table below showing the number of subatomic particles in this atom of argon. Use the periodic table as a source of data. So argon has a mass number of 20, and it has an atomic number. If you look at the periodic table where's argon? Argon is in group 8. It's in period 3. So we see that it has a mass number of 40 and it has an atomic number of 18. So the number of protons is 18. The number of neutron is 40 minus 18, which is 22. And the number of electron, it's not 9, so it's the same, 18. So 18, 18, and 22. 18, 22. So an atom of potassium has a mass number of 39. Explain why argon is placed before potassium in the modern periodic table. Okay, this is a simple answer. We know that the modern periodic table is arranged according to the atomic number and not the mass number. So the reason is because the modern periodic table is arranged according to its atomic number and not the mass number. It's because the periodic table is arranged according to its atomic number and not the mass number. Next question. The nucleus of A, 23, mass number of 23, atomic number of 11, sodium atom contains, it's very simple, 11, atomic number is 11, so 11 proton, so one of these two, and 12 neutron, because 11 plus 12 is 23. So A is the answer. Now, naturally occurring samples of potassium contain 3 isotopes, K39, K40, and K41. The isotope can be separated in the mass spectrometer. In the diagram below, particles are ionized at A and detected at B. Okay, name the processes occurring in the mass spectrometer at B and C. So we said that over here it's ionized, over here it's accelerated, over here it's deflected and detected. So B is acceleration and C is deflection. Acceleration, C is deflection. Perfect. A sample of potassium has the following composition. Calculate isotope K, whatever. Calculate the relative atomic mass of this sample of potassium, giving your answer to do decimal place. So we said that the AR equal to the mass of an isotope times its abundance plus the mass of another the isotope divided by its abundance, no, multiplied by its abundance, plus the mass of the other isotope times by its abundance. So 93.22 times 39 plus 0.12 times 40 plus 6.66 times 41, and the whole thing divided by 100. So you should get 39.1344, giving your answer in 2 decimal place, so 39.13. Now, complete the table below to show the nucleus of subatomic particle in an atom of each isotope. So K39 and K41. So it has mass number of 39, and I think you have to look at the periodic table. Yes, you do have to look at the periodic table. So K, potassium. Potassium is in group 1. It has an atomic number of 19. So 19 electrons, 19 proton, and over here it's 19 electron, 19 proton. So neutrons is the mass number 39. 39 minus 19 is 20, and over here it's 22. So 19, 19, 20, 19, 19, 22. Yep. Thank you very much for listening. See you in the next video, and if you enjoyed, don't forget to subscribe, share, like, recommend it to your friend, and most importantly, stay safe. Bye.